आवाज नहीं हेलो Good afternoon, everyone. A warm welcome to all the participated guests. Hello, hello. Audible?
Ma'am, your audio is not clear.
Not audible.
No. Sorry, ma'am, not audible.
Hello. Hello. Am I audible? Am I audible? Am I audible? Am I audible?
मैम एको आ रहा है.
Hello, am I audible?
Yes, Sweta, you are audible. Now you can start.
Good afternoon, sir. To all the participants, respected guests, speakers, organizers, and participants joining us from different part of the world. I am Shweta Gupta, and it is my honor to serve as your anchor for today's international conference on recent development in science and technology for achieving sustainable goals using statistical techniques 2025. This conference is organized by the MIT School of Applied Sciences, ASAS, MIT, Uttar Pradesh, Lucknow campus, in collaborations with Science Tech Institute, Lucknow. Today's conference covers a wide range of topics, including mathematical modeling, environmental science, biostaticals, computational science, and much more. Before we begin, a gentle reminder to all the participants. Please keep your microphones muted unless invited to speak. Kindly post your queries in the chat box. Select questions will be taken up during the question and answer session. It is my honor to invite and warmly welcome our session chairpersons and judges for this session. Dr. Ambrish Kumar, sir, Assistant Professor, MIT School of Applied Sciences, MIT University, Uttar Pradesh, Lucknow campus, and Dr. Sampriya Trivedi, Assistant Professor, MIT School of Applied Sciences, MIT University, Uttar Pradesh, Lucknow campus. We are truly privileged to have their estimated presence and guidance for this session. We have a truly fascinating lineup of presentation ahead of us. Without further ado, let's begin. I'm pleased to invite number 13, Mr. Mahesh Dibyakaran, to present his paper titles Machine Learning Based Hybrid Framework for Multi-Omics Data Modeling a Systematic Review. Over to Mahesh, please. Screen is your Mr. Mahesh. Mahesh, I don't think. No, ma'am. Vicky Kumar. Vicky Kumar is there?
Yes, ma'am.
Now, for the question to your table. Hello.
Hello, ma'am.
Please share your screen. Hello.
Yes, ma'am.
Please kindly share your screen. Or, yeah, your screen is over.
Ma'am, picking is visible.
Yes, you are audible. Go ahead.
Hello. Your voice is not clear.
One second, ma'am. My PPT is visible, ma'am.
Your voice is flat.
Hello.
You are just 10 minutes.
Hello.
So please start your presentation.
Ma'am, my PPT is visible. Ma'am, your voice is fluctuating.
Your slide is visible. Now you can start.
Okay, sir. Good afternoon, everyone. Myself, Vicky Kumar, pursuing PhD in statistics under the supervision of Professor Sunil Kumar from Central University of South Gaya. My topic is prediction the determinants of malnutrition with reference to the NFSS 5 data. In content parts, we include the introduction, review of literature, objective, methodology, results, discussion, conclusion, and references. Here we have made. Hello. Hello.
Hello, Vicky, am I audible?
Yes, ma'am. Ma'am, but your voice is fluctuating.
Just 10 minutes.
What, ma'am?
Yes, yes. So be concise your presentation. Okay?
Okay, go ahead.
Oh, okay, sir. Now, stunting is low weight, low height for age. That means according to age, our height are not growth. It is also known as chronic malnutrition. And another term is underweight. This is also known as chronic and acute malnutrition. Underweight means low weight for age. That means if our age is increasing, but according to age, our weight is not increasing. And third one is low birth weight. That means when a baby born with a weight less than 2.5 kg or 2500 grams, then babies are forms in the category of low birth weight. And another term is wasted. It is comes, also known as the acute malnutrition. Wasted means low weight for height. That means when height is increased, but height is not increased according to weight. First here we see the chart of malnutrition. Malnutrition means when we not uh, when we not diet in proper nutrients. मैम जैसे कि हमारे जो जितना मात्रा में हमें चावल खाना है तो उससे अगर हम ज़्यादा खा लिए या कम खा लें तो वो मालन्यूट्रिशन कैटेगरी के अंदर आता है। अगर हम ज़्यादा खा लिए तो ओवरवेट हो गया, और अगर कम हमें खाना मिल रहा है, कम हमें पोषण तत्व मिल रहा है तो वो अंडर न्यूट्रिशन कैटेगरी के अंदर आ गया। और अंडर न्यूट्रिशन भी को भी 3 भाग में डिवाइड किया गया है, स्टंटिंग, वास्टिंग एंड अंडरवेट। स्टंटिंग में लो हाइट फॉर एज, मतलब एज के अनुसार से हाइट का ग्रोथ नहीं होना। वास्टिंग मीन्स लो वेट फॉर हाइट, हाइट के अनुसार से वेट का ग्रोथ नहीं होना। एंड अंडरवेट मीन्स लो वेट फॉर एज के अनुसार वेट का ग्रोथ नहीं होना। एंड ओबेसिटी मीन्स here in this chart we see that 4 person, one is normal, another one is wasting, and another one is stunting and underweight. And in lower this we see low birth weight baby. लो बर्थ वेट कोई बीमारी नहीं है, लो बर्थ वेट के कारण बीमारी होती है, और वो बीमारी है वास्टिंग, स्टंटिंग, अंडरवेट, इस कुपोषण के शिकार हो जाते हैं। This is our introduction part. Malnutrition is continued to be a major health issue for the Indian children whose age is less than 5 years of age. It is caused by multiple factors and has both short and long-term negative health effects. This is the guideline of WHO and in 2013 and by Pumela in 2009. Due to malnutrition problems, not only the cognitive and physical development of the child is affected, but also the morbidity and mortality of the baby are significantly increased. In general, the nutritional status of a child is assessed by three widely used indicators, that means stunting, fasting, and underweight. According to Dionis and Rosner in 2003, stunting and fasting indicates chronic and acute malnutrition respectively, whereas underweight is a composition from of both stunting and fasting. The undernutrition problem caused at least 50% of the total deaths annually in the children who aged 5 years, less than 5 years, according to Lloyd in 2015. The WHO reported that at least 155 children within whose age less than 5 years of age are stunted, 52 millions are wasted, and 99 millions are underweight, respectively, global through the globe, according to WHO and Black et al. In 2013. Moreover, in South Asia, the prevalence of malnutrition is high in three countries: India, Pakistan, and Bangladesh, according to Hadley et al. In 2016. The factors mostly contribute to the malnutrition issue are socio-economic inequalities, geographical differences, optional feeding, and practice of household food insecurity, maternal literacy, and childhood morbidity. According to WHO in 2015, three-quarters of the world low birth weight newborns were born in three regions. In South Asia, 47%, in Eastern and Southern Africa, 13%, and in West and Central Africa, 12%. In India, about 32 to 40% newborns are born with low birth weight. This is the huge problem in India. Considering the low birth weight amongst tribals, every fifth newly born child is reported to low birth weight in 165 districts of India, according to Kanjari et al. In 2021. Birth weight refers to a newborn's first weight, which is normally taken shortly after birth. A newborn baby physically maturity can be determined by its birth weight or gestational age. Infants born with a low birth weight face a variety of health problems throughout their life. This is our review of literature part. According to Dowdry and Jones in 1982, found that the birth weight increased by 13.6 grams per day during the week of pregnancy. The birth weight is continuing to increase up to 40 weeks, beyond which the relationship between the birth weight and gestational period becomes skewed and even somewhat negative for longer gestation period. According to Solstek et al. In 1984. According to Edison and et al. In 1984, Bhatia and Tyagi in 1984 also confirmed that birth weight is directly related to maternal height, when all other variables are kept in a controlled environment. If, according to Niger et al. In 1986, if the height of the mother is less than 148.5 centimeters, then the mean birth weight of the child at birth will be low. According to Thompson et al. In 1986, so that consistently, there is no difference in birth weight for gender until 34 to 35 weeks of gestation period. After 38 weeks, males are about 150 grams heavier than female. According to Kessel et al. In 1985, discussed that the rural residents, marriage at a younger age, low education level of mothers, and previously poor pregnancy outcome are the important factors for contributing for low birth weight. Low birth weight is a serious health problem in low and middle income countries and a leading cause of death in the first month of life. Some of the studies already evaluated the relative importance of major anthropometric indicators, social, demographic, and economic variables, including maternal nutritional status on low birth weight children based on National Family Health Survey data. The nutritional status and now the current 1987, Kramer discovered that low birth weight is connected to malaria, birth or pregnancy intervals, cigarette smoking, alcohol use, tobacco chewing, general morbidity, gestational nutrition, and caloric intake, preterm birth history, birth weight, parenthood, maternal height and weight, antenatal care visit, marital age, maternal height, maternal pre-pregnancy weight, prior stillbirth or neonatal death during the study. However, these studies were restricted to a particular geographical location of India. And this is our objective. First one is to assess the impact of demographic determinants such as child age, weight, and height on low birth weight, stunting, underweight, and wasting among the Indian children whose age is less than 5 years. Second one is to evaluate the impact of important contributing factors like pregnancy duration, case of twin child, low birth weight, and prenatal care visit, and source of drinking.
Hello.
Amen.
Hello. Vicky.
Yes, ma'am.
You just have one.
Ma'am, your voice is fluctuating. I am not audible. What you want to? Hello, ma'am. I am audible. Hello.
Yeah.
Hello. Sir, what are you saying? I am not listening properly. Hello. Hello.
Audible to you?
Yes, sir. Yes, sir.
Okay. So please maintain the time. You have only 10 minutes and 10 minutes
Oh, okay,
for
sir. Okay, okay, sir. This is our objective part, and now we go on the conclusion part.
finish as soon as possible.
Um, um, Sir, only 2 minutes. Only 2 minutes. Give me 2 minutes.
Okay. So go ahead.
Okay. Oh, okay, sir. Thank you, sir. And third one is to assess the effect of cigarette smoking, tobacco, and alcohol consumption on low birth weight, stunting, underweight, and wasting in India, whose age is less than 5 years of age. And this is our methodology part. We convert NFHS data, and this is our independent variable due to his insufficient time. We not discuss. This is our model. What we use regression model, univariate, multivariate, and this is the graph where we use which type of models. And this is logistic regression. We use it, and here we see that it's wide function. Here the odd ratio, what odd ratio say. Um, this we get in result from chart. We see that 57.7% are not stunted, 30.5% 8.5 are moderate stunted and 11.8 are severely stunted. This is our chart, and this is the percentage of low birth weight, stunted, wasted, and underweight. 30.76 are low birth weight, 30.98 are stunted, so and 22.03 are wasted, and 29.21 are underweight. This is the variable which affect low birth weight and its contribution, and this is the variables which affect stunted, and this is the underweight. This is our result. This is our discussion part. Due to insufficient time, we will not discuss it. This is our conclusion part. Being a serious health problem among children below 5 years in developing countries, malnutrition is very much associated with multiple factors, resulting in several health complications in India. And malnutrition is a key contributor to both acute and chronic disease among children, affecting both cognitive and physical development. Our study also found that both maternal and child-related factors are associated with malnutrition in Indian children, and most of them are preventable. To eradicate this malnutrition, strategies and goals to be fixed by both center and state authorities. Awareness must be created among the people regarding mothers' education, nutrition, and healthcare services must accessible and affordable to all pregnant women, irrespective of community, caste, or tribe and religion. Other modes that can address these factors are required, such as community-based education, promoting nutrition, sensitive agriculture, improving women's status. Intervention programs must be included among most desired communities for the best result in future. This is our references for. Thank you, sir. सस्टेनेबल मालन्यूट्रिशन को मोदी ने कम करने के लिए सस्टेनेबल डेवलपमेंट गोल के दो में रखा है, 0 फॉर हंगर, और आगे इसके ऊपर और काम किया जाएगा.
Hello.
हेलो. हेलो.
Hello.
मैम, हाँ मैम, योर वॉइस इज फ्लक्चुएटिंग मैम.
Hello.
हेलो. हेलो मैम.
Thank you, Vicky.
आई एम ऑडिबल मैम.
You are audible. Thank you for your presentation.
Thank you. Okay, ma'am. Thank you. Sorry for consuming more time. Hello.
Then I request you number 15, Neeraj. Now I call number 17, Akansha Upadhyay. Akansha Upadhyay,
Yes, ma'am.
you are requested to present your paper.
Okay, ma'am. Ma'am, am I audible?
Yeah, you are audible. Please share your screen.
Mm. Good afternoon, everyone. Myself, Akanksha Upadhyay. I'm currently pursuing my PhD under the supervision of Dr. Kamlesh Kumar sir. I'm from Department of Statistics, Central University of South Bihar. So for today's presentation, my topic is estimation of population proportion using auxiliary attribute in two-phase sampling. So these are the outline which I'm going to discuss. First, we'll see introduction, then sampling method and notation, existing estimator, proposed estimator, theoretical comparison, result and conclusion, and then references. First one is introduction. Estimation of population proportion is one of the core objectives in survey sampling, as it provides valuable insight into the distribution of qualitative characteristics within a population. Such measures are widely applied in agriculture, health sciences, economics, and social research, where accurate assessment of prevalence is essential for planning and policy formulation. However, conventional estimators derived under simple random sampling often suffer from low efficiency, particularly when the study attribute is rare, costly, or difficult to measure. Most existing studies in survey sampling highlight the role of auxiliary attribute in improving the efficiency of estimators, but a common assumption is that the population proportion of the auxiliary attribute is known. So numerous estimators have been suggested by Ahmades, Alorini Diab, and Ahmad for estimating the population proportion in case of known population proportion of auxiliary attribute. It has been found that no research work has been done for estimation of population proportion of study attribute in case of unknown population proportion of auxiliary attribute. So motivated by this gap, we have proposed a generalized and general class of estimators for population proportion of study attribute using auxiliary attribute in two-phase sampling. Their properties are also studied and mathematical comparison of the proposed estimator are also given. Next, we have the notations. So we considered a finite population of size capital N with elements psi, which consists psi1, psi2 up to psi n, and let phi y and phi I1 denote study and auxiliary attribute. So these are the notation for sample proportion, small pj dash in first phase, and capital Pj dash is for population proportion. Next, we have phi rho phi y phi 1 is the population correlation coefficient, and S phi y phi 1 represents the population covariance among study and auxiliary attributes. After this, the standard deviation of the study and auxiliary attributes are defined as S phi y and S phi 1. And next, the coefficient of variations are given as C phi j, means for study variate, it will be C phi y, and for auxiliary attribute, it will be C phi 1. Next, we have the error terms epsilon naught, epsilon 1, and epsilon 2. Then we have the variances epsilon naught square, even square, epsilon 2 square. Then we have the covariance system where gamma 1, gamma 2 are the constant. And next we have the existing estimators. This section highlights some of the widely adopted estimators for population proportion under two-phase sampling. First one is the usual estimator for population proportion, which is defined as T1 hat is equals to Py. In case when the population proportion of the auxiliary attribute is not known, we take a first phase sample of size n dash from a population of size capital N using SWOR. Further, we compute the first phase sample proportion P dash from n dash units. Again, we take a second phase sample of size n from the first phase sample n dash using simple random sampling without replacement and compute the second phase sample proportion Py P1 for the study attribute and the auxiliary attribute from n units. Next, we have the defined ratio and product estimator for population proportion under two-phase sampling. So T2 is the for ratio population proportion estimator in case of two-phase sampling, and T3 is for product. Next, we have the bias and mean squared error for the existing estimator. Equation 4 and 5 are the bias of T2 and T3. Then we have mean squared error for the existing estimator T1, T2, and T3. Again, gamma 3 here is a constant. Next, we have the proposed estimator. In two-phase sampling, we have proposed the following generalized ratio and the general class of estimator. So T4 and T5 are the proposed estimator, where in T5, the alpha and beta are the constant and lambda lies between 0 and 1. So this table shows the special cases of the proposed estimator. For different values of constant alpha, beta, and lambda from the proposed estimator T4 and T5, we derive the special case. Means if we put the values of alpha in proposed estimator T4, we get the different values. We get the different existing estimator like T1, T2, T3, and for same for the T5, we put different values of beta and lambda here, and we got four estimator T1, T2, T3, and T4. Next, we have the mean squared error of the proposed estimator. First, in equation 11, we have the mean squared error for T4 in where alpha is a constant. And when we differentiate equation 11 with respect to alpha, we get the alpha optimum values, that is C5 y phi 1 upon C5 square 1. Then after putting the value of alpha optimum in equation 11, we got the new MSC expression that is represented in equation 12. Next, we have the mean squared error for proposed estimated T5 in equation 13. Then we differentiate the equation 13 with respect to lambda and beta. We got the two values, one for lambda optimum and one for beta optimum. Then we put these two values in equation 13. We get these new expression for MSC. Next, we did the theoretical comparison between the proposed estimator with that of existing ones. So first we have for T4, we compared our mean squared error for T4 with the variance of T1. If MSC T4 is less than variance of T1 if alpha lies between 0 and 2C551 upon C square 51. And second, MSC T4 is less than MSC T2 if the values of alpha lies between 1 and 2C551 upon C square minus 1. Then next we have MSC T4 is less than MSC T3 if alpha lies between -1 and 2C551 upon C5 square plus 1. Next, same for proposed estimated T5. We compared their mean squared error with the existing one. First, we have MSC T5 is less than variance of T1 when if the value of beta lies between 0 and the 2C5 C51 upon 1 minus lambda C51. Same for the MSC T5 is less than MSC T2 if the values of beta lies between these two values. Next, we have the 45. Again, we compare it with MSC T3. Then, if it will be less than MSC T3 if the values of beta lies between these two values. Next,
Hello.
we did an yes, ma'am.
Hello. You just
Yes.
have 2 minutes. So please, as soon as possible, winding up.
Okay, ma'am. Okay, ma'am. We did an empirical study for to check our performance of our proposed estimator. So I took these two real data sets from a published paper by Kumar and Singh sir. These two data set are these notations which are given here. This is data set 1, this is data set 2. And we did this empirical calculation, and here we can see for both the data set 1 and data set 2, if we see the proposed estimated T4 and T5 have the lowest or the smaller mean squared error as compared to the existing estimated T1, T2, and T3. Next, we have the result and conclusion. So, in the present paper, we have proposed a generalized ratio estimator and general class of estimator for the population proportion using an auxiliary attribute in two-phase sampling. But the result we obtained in table shows the proposed estimator T4, T5 have lower MSC in comparison to the relevant estimator, such as mean, ratio, and product. We also observed that the proposed estimator are more efficient in comparison to the earlier existing estimator as its MSC are lower than the existing ones, such as mean, ratio, and product. Therefore, we can recommend these estimators for estimating the population proportion of the study attribute in a sample survey. So these are the references. Thank you everyone for your kind attention.
Okay, good. But I have a question, Ansha.
Yes, ma'am.
Am I audible to you?
Yes, sir.
Is there any utility in real life of your paper? Can you elaborate it?
Sir, please repeat your question.
Utility of this research, whatever you are explaining over here, is there any utility in our real life? Can you give me some example or any one example which I can understand?
Sir, we can apply this method, particular estimators, to estimate sir, in agriculture or health sciences. I mean, if you want to
Estimation of what?
estimation of study attribute means a study attribute.
Okay.
Yes, sir.
Okay. Thank you.
Okay. Thank you so much, sir.
Akansha. Now
Yes.
I invite number 18, Miss Akriti Bharadwaj, to present her work on estimations of population mean in the presence of non-response and measurement error under double sampling. Hello.
Yes, ma'am.
Yeah, please share your screen.
Ma'am, my
Yeah,
screen is
all visible. Right.
okay.
You just have 10 minutes. So please.
Okay, ma'am. I'm audible?
Yeah, you are audible.
Yes. Uh, Good afternoon, everyone. Myself, Akshi Bharadwaj, a research scholar, Department of Statistics, St. John's College, Agra, under the guidance of Dr. Namita Srivastav, HOD, Department of Statistics, St. John's College, Agra. Today, I am here to present my research paper on the topic of estimation of population mean in the presence of non-response and measurement error under double sampling. So, firstly, we discuss about objectives and motivation of our topic. So my first objective is to provide a robust estimation framework for the population mean. And the second is to address two common challenges in survey sampling, non-response and measurement error. And my third objective is to show how double sampling can be effectively combined with advanced statistical technique to produce more reliable estimates. And sorry. Sorry, ma'am. Motivation of my topic is accurate population mean estimation is critical for evidence based policy making in areas like agriculture, policy, public health and socio-economic, which directly impact the evidence of sustainable development goals. And the presence of non-response and measurement error can significantly compromise the validity of presence of these estimates, leading to beside conclusion and ineffective policies. Now, introduction of my research work. Population studies provide us with very important information that help us make good decisions, but survey often have two main problems. First is non-response and second is measurement error. Now we discuss non-response. Non-response occurs when researcher failure to collect information on one or more than one unit of the survey. Non-response can be classified into two types. First, unit non-response, and second, item non-response. Unit non-response, the entire survey is left incomplete by respondent, that is unit non-response. And item non-response, some specific questions are not answered by respondent, that is item non-response. Impact of non-response. Impact on non-response totally depend on the nature of the non-response. Random non-response and systematic non-response. Random non-response, the non-responding units are random subset of the sample. The primarily affect variance, increasing the sampling error. And systematic non-response, the non-responding unit differ systematically from the respondent on the key characteristics. These introduce bias into the estimates. And then measurement error. What is measurement error? Measurement error is a difference between the observed value and the true value. And this come for various reasons like instrumental error, respondent error, and proceeding error. Both issues introduce bias and increase the mean square error of estimator, compromise the accuracy and reliability of results. Statistical techniques are important to reduce these effects, ensuring that researcher findings are robust and applicable for sustainable development efforts. Now we discuss about double sampling. What is double sampling? Double sampling is a method where data collected happen in two steps or phases. In the first phase, a large sample is drawn from population and only basic or easy to correct information is recorded. And the second phase, a small sample is selected from the first phase sample and more detailed or often more expensive or time consuming information is collected from this group. Now, review work. Here we divide our review work in three steps. Researchers who work on non-response, researchers who work on measurement error, and researchers who work on non-response and measurement error simultaneously. Next, estimation framework. To estimate the population mean, we take a population of n units and we assume that y is a steady variable, capital X is an auxiliary variable, n dash is a first phase sample size, and n is the size of second phase sample. And now we divide n into two groups, n1 and n2. n1 who respond at the first attempt of for study variable and the auxiliary variable, and N2 they did not respond at the first attempt. Here R unit are selected at random without replacement from the N2 unit, where K is the inverse sampling ratio. Now, in continuation, mu y we taken as population mean of y, mu x a population mean of x. Here y bar and x bar are the sample mean of y and auxiliary variable x respectively. Sx square and sy square are the variance of study variable and auxiliary variable, and sxy is the covariance between y and x, and rho yx the correlation coefficient between y and x. Now, if we consider the measurement error on the study variable y and the auxiliary variable x, then xi and yi are the observed value with measurement error I sample unit, and capital Xi and capital Yi are the true values. Then the measurement error for study variable is Ui is equals to small yi minus capital Ya, and measurement error for auxiliary variable is Vi is equals to small xi minus capital Xi, which are stochastic in nature and uncorrelated with mean 0 and variance Su square and Sv square respectively. In the presence of measurement error, the population variance of U and V for the non-respondent group are SU of 2 square and SV of 2 square. Now, if we consider the non-response and measurement error simultaneously, the variance of study variable Y, we show that by y bar double star under double sampling scheme. So variance of y bar double star is this, and variance of x bar double star is this. Now, these are some other notations that we use in our. Yes, ma'am.
Try to wind up as soon as possible because
Ma'am, your voice is not clear. Okay, ma'am, but I'm trying to fast. Okay, ma'am, as existing and adaptive estimator. For comparing our proposed estimator, we use some traditional estimator like mean estimator, ratio estimator, product estimator, and regression estimator. We denoted mean estimator by T1, and MSE of T1 is this, and we denoted ratio estimator by T2, and MSE of T2 is this, and product estimator denoted by T3, and MSE of T3 is this, and the regression estimator denoted by T4, and the MSE of T4 is this. Now our proposed estimator. In this section, we suggest a class of estimator, especially for estimating population mean under double sampling in simultaneous presence of non-response and measurement error, which is defined as TA. Here TA is this, and here alpha and beta are given constant, and D1 and D2 is chosen by minimizing MSE. Actually, my MSE's expressions is very lengthy and complicated, so I try to in MSE in minimizing form. So my estimator's MSE is this, and the values of M and O, P, Q is this. And now, to get the optimum value of D1 and D2, differentiate previous equation with respect to D1 and D2 and get the value of D1 and D2. And by putting the value of D1 and D2 in the MSE's equation, we get the final MSE of TA. Now, numerical study. To evaluate the efficiency of our proposed estimator with respect to the other existing estimator, we use real data set MU284 taken from Appendix B of the book by Sander et al. 2003. This data set contains 284 entries. Now, here we assume 1985 as study variable, and the measured study variable taken as y is equals to capital Y plus n 1,3, and then u is equals to small y minus capital Y, and the population of 1975 as auxiliary variable and measured auxiliary.
Krishi,
Yes, ma'am.
your time is over now, so please explain your conclusions.
Ma'am, please, ma'am, please give me 2 minutes only. I explain my table and MSc and PRE.
Please, because we have a another participant. So your time is over now.
Okay, ma'am. So, ma'am, I show that by first table, uh, the MSE of PREs of my estimator is better performed by other existing estimator for all combinations of alpha and beta and for all different conditions they be taken. Ma'am, now I come to my result. These are for k is equals to 4 RMSE and PREs result. The findings present in table 1 through table 4 table 4 highlight the performance of the proposed estimator under 9 different combination of the parameters alpha and beta evaluate across 4 different sections simultaneous presence of non-response and measurement error, presence of non-response only, presence of measurement only, and absence of both error. The table 1 and 2. In table 1 and 2, we take the value of k is 2 and 3 respectively. The result demonstrates that proposed estimator constantly outperform existing estimator in the terms of mean square error and present relative efficiency across all 9 combinations of alpha and beta. Similarly, for table 3 and 4, we take the values of k is 4 and 5 respectively, and the analyze realize that the proposed estimator maintained superior performance across all combinations of alpha and beta under all 4 conditions. Now,
Akrashi, because her time is over now.
okay, ma'am, this is my conclusion, and mm, ma'am, I have 2 minutes only, ma'am. 2 minutes. Give me, please.
Okay, fine.
Okay, ma'am. And this is my conclusion. Our new estimator constantly perform better than other estimators like mean ratio product and regression estimator is it's especially useful when people don't answer survey or give wrong answer and when we don't know the average of the extra information we are using. While a few specific cases showed similar result, our new estimator was generally much more reliable and robust. These are references, and thank you, ma'am.
Okay.
Thank
Okay,
you.
thank you.
Thank you, Miss Akriti. Now I request to number 19, Amrishwata C.
Am I audible?
Yeah, you are audible. Please share your screen.
Yes.
Amrishwata, you just have 10 minutes, so please try to bind up in between
Okay,
10
ma'am.
minutes.
Okay, ma'am. Hello, good afternoon, all. I'm Amaraswada C, Research Scholar, Department of Statistics, Farouk College, Kerala, under the guidance of Dr. Nasima BVT. My presentation title is Recent Advancement in Distribution Regression, a Review. These are my contents. Introduction. Regression analysis is a fundamental tool in statistics and machine learning used to estimate the conditional mean of a response variable given one or more covariates. In many real-world scenarios, knowing only the mean is not sufficient. Researchers need to understand the full distribution of outcomes such as variance, skewness, and quantile. Over the past years, numerous methods have been developed in the field of distributional regression. These includes generalized additive model for location, scale, and shape, boosting algorithm, Bayesian approaches, tree-based models, index model, and isotonic distribution regression. Each of these methods has several advantages depending on the nature of the data. Motivation. We are motivated to do this review by the fact that classical regression methods focus only on the conditional mean. In practice, the mean alone is insufficient for decision making. Real-world application require understanding the entire conditional distribution. Generalized additive model for location, scale, and shape was developed by Rigby and Stansonopoulos in 2005. This model overcome the limitation of GLMs and GIMs in which response variable should follow exponential family. This condition is relaxed in GIM LSS. JAM LSS allows general distribution families, including highly skewed or kurtotic, continuous and discrete distribution. Systematic part of the model include parametric or additive non-parametric function of explanatory variables or random effect terms. LSS can model not only mean but also other distribution parameters. Mayer et al. In 2012 extended generalized additive model for location, scale, and shape to a high-dimensional setting by proposing a boosting algorithm called GAMBoost LSS. For high-dimensional dataset, current GAM LSS fitting algorithms are infeasible and require variable selection based on information criteria. The new algorithm enables simultaneous estimation of predicted effect and variable selection. Condell regression forest. Condell regression forest was introduced by Mainhausen in 2006 as an extension of random forest. Condell regression forest infers conditional Condell rather than only conditional mean. Application of Condell regression forest includes detecting outliers and constructing prediction interval. For high-dimensional predictor variable, Condell regression forests provide a precise and non-parametric method of estimating conditional Condell with certain assumption. The algorithm outperform linear and tree-based method on common machine learning benchmark problems. Isotonic regression. Isotonic regression is a non-parametric technique used to estimate function under the assumption that the response variable is monotonically increasing or decreasing with respect to the covariates. Les and Rosset proposed a partitioning algorithm in 2011 to address large-scale generalized isotonic regression problems. The algorithm performed well on real and simulated data in two scenarios, fitting count data with negative Poisson log likelihood laws and fitting robust isotonic regression with Huber's laws. Jordan et al. In 2019 studied the isotonic regression problem from a decision theoretic perspective, focusing on the optimality properties of the isotonic regression estimator under convex loss function. The study provides theoretical support for the application of isotonic regression outside traditional squared setting by defining circumstances the proposed causal isotonic regression, a method for estimating monotone causal dose-response curve under confounding. Hensey et al. In 2021 introduced isotonic distribution regression, a fully non-parametric method for conditional distribution estimation under monotonicity constraint. They developed a pool adjacent violators algorithm, which is an efficient algorithm. Empirical studies in areas such as probabilistic precipitation forecasting shows that isotonic distribution regression outperforms standard approaches, and this established it as a major contribution to the field of distribution regression. Monotone single index model. Monotone single index model is a regression model in which response depend on a single linear combination of predictor transformed by an unknown monotone link function. Balade et al. In 2017 examined estimation technique with the framework of the monotone single index model. Traditional least square estimator in monotone single index model converge slowly and are not asymptotically normal, making inference difficult. The author proposed score-based estimator which are based on the first order condition of the least square criteria to overcome this constraint. Hello. Yes, ma'am. Two primary methods are examined, namely Lagrange multiplier approach that integrates the constraint directly into the optimization process and sphere parameterization methods that reformulate the unit norm constraint of the parameter vector using local coordinate. Both methods yield asymptotically normal root and consistent estimator. Balade et al. In 2019 studied the monotone single index model where both the index parameter and the monotone link function are unknown. Least square estimator achieve cube root and rate convergence of for the regression function as well as for the independent estimator of the index and ridge function. The least square estimator achieve nearly parametric rate in certain situations such as red function is piecewise constant. Bayesian framework for structured additive distribution regression Klein et al. In 2015 proposed a unified Bayesian framework for structured additive distribution regression with multivariate responses. This framework extends univariate approach and allows all parameters of the complex multivariate distribution to depend structured additive predictor. It enables modeling not just mean but also variance correlation and higher moments of the response distribution. Distributional regression forest. Scholars et al. In 2019 introduced distributional regression trees and forests extending classical regression trees and random forests to model full conditional distribution of response variable. The technique can automatically choose variables and interaction while capturing changes in location scale and shape parameter by incorporating likelihood-based score function from the GAMLS framework into recursive partitioning. In 2022, Sevid et al. Introduced a non-parametric machine learning method called a distributional random forest, which is designed to estimate full conditional distribution rather than only mean or condials. This method generalized a random forest algorithm by adding splitting criteria based on distribution distance and reweighting observation to capture full conditional distribution. Distribution single index model. Hensi et al. In 2021 introduced distribution single index model, a semi-parametric framework that combines the dimension reducing structure of single index model with the flexibility of isotonic distribution regression. Distribution index model are invariant under monotone transformation of the index and response and strike a balance between tractability and flexibility by projecting covariate onto a parametric index and estimating conditional distribution non-parametrically under monotonicity constraint. Distributional index model produce calibrated and precise probabilistic forecasts that outperform techniques like Cox regression and Condell regression.
Amrashwata,
Yes, ma'am.
try to bind up just in 2 minutes because your time is over now.
Yes, ma'am. I will. Paladwe et al. In 2023 developed theoretical properties of distribution index models, probabilistic forecasting. Knighting and Kappas presented a detailed review of probabilistic forecasting. A probabilistic forecast is expressed as a probability distribution that describes possible future values or event. The main aim of probabilistic forecasting is to make predictions that are as sharp as possible while still being well calibrated. Probability integral transform histogram can be used to check whether forecasts are properly calibrated. Measures such as logarithmic scores and continuous rank probability score help to evaluate both calibration and sharpness. Consistent scoring function provides sound decision theoretical way of evaluating point forecast. Conclusion and future work. We reviewed the literature on distributional regression and summarized the major development in this field. The method include GAM, LSS, Bayesian approaches, tree-based method, isotonic regression, and index models. Future work include improving computational efficiency so that distributional regression method can be applied to a large-scale and high-dimensional dataset, strengthening the theoretical foundation by exploring convergent properties, optimality, and robustness of this method, and integration of distributional regression with modern machine learning technique, which can increase flexibility while ensuring interpretability. These are my references.
Sir, have you any question?
No?
No, ma'am, you are not audible. Hello. Listen, you are audible now.
Okay. Hello.
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 Yes. Hello, dear. I have one question.
Yes, ma'am.
Yes, you have used Bayesian approach, right?
Bayesian approach, Bayesian additive structure regression.
So, can you give me the Bayesian approach example in real life?
Ma'am, it is Bayesian additive. I can show you the slide.
Yes. I know Bayesian adaptive model. I'm saying that conclusion you mentioned you have used the Bayesian approach. So my question is, what is the significance of Bayesian approach in statistics?
Statistic. Can you repeat the question, ma'am?
What is the significance of Bayesian approach in statistics? Bayesian, do you have any idea about Bayesian, dear?
When we have a prior, when we have, yes, ma'am, when we have a prior information with us, we can use it. Hello, am I audible?
Yes, dear.
Hmm.
Okay, thank you, Bachchan.
So here,
Thank you, Miss Amrishwata. Now I request to number 20, Miss Amruta PT.
Yes,
Amruta,
ma'am. Yes, ma'am.
please share your
Yes.
screen.
Okay. Am I audible, ma'am?
Yeah, you are audible.
Okay.
You, Amruta, please remind that you just have 10 minutes, so try to bind up between 10 minutes.
Okay. Okay, ma'am. Okay. Okay. I'm Amrita. I'm doing a PhD under the guidance of Dr. Rijita CS in the Department of Mathematics, Amrita Vishwavidyapitham, Tamil Nadu, India. First of all, I will thank to the organization committee of the International Conference on Research Development in Science and Technology for achieving sustainable goals using statistical techniques, for giving me an opportunity to present my paper, Parameter Estimation of Transmitted Tertiary Distribution using BNN, Bayesian Estimation, and MLE approaches and its applications. So this is my outline of the presentation. So we are all,
Hello,
we are all,
Amrita.
yes, ma'am.
Dear, skip the introduction part. Okay.
Okay, okay.
Show me your objective and the results. Okay.
Okay, okay, ma'am. So we are all dealing with the data-driven environment and dealing with the environmental data. So probability distributions play a vital role to analyze such data and gives accurate inferences. So these are my literature review. In 1934, the Tessier introduced Tessier distribution for modeling the mortality of domestic animals species as a result of pure aging. In 1958, George proposed exponential distribution. It is the most popular distribution because the PDF and CDF are very simple and it have a constant hazard rate. So to overcome the difficulty of the exponential distribution, Linley proposed Linley distribution, and it has increasing failure rate. And Schoen Buckley introduced the quadratic span rank transmutation map. It is one of the easiest way to generalize the existing distribution. As Alcetra et al. Introduced the transformed transform family to generalize the existing distributions. So this is my objective. Even though there are many distributions present in the literature, still the researchers are trying to introduce a or develop a very flexible distribution to model the complexity of the real data. So we have introduced a more flexible generalization of the Tessier distribution called transmuted Tessier distribution or TTD. So when the PDF or CDF become complex, their derivation, their estimation of the parameter also will be become complex. So since the estimation, so we introduced the Bayesian neural network, that is a machine learning technique to estimate the parameters of the distribution. So this is the Tessier distribution, transmitted Tessier distribution. The PDF is given by the equation 1. So this is the plot of the CDF for different combination of the parameters. This equation 2 will give the PDF of the PTD, and for various combinations of the parameter, it will give the various shapes. It is plotted in here. So these are the properties I have derived for the TTD. So moments is given by equation 3. Moments provide vivid characteristics of the PDF, and the order statistics is given by equation 4. Condyle function is given by equation 5. Condyle function we can use for simulation. and it is inverse of the CDF. Then moment generating function is given by equation 6. Moment generated, MGF is also used for generating moments like mean, variance, condyles, etc. So these are the three parameter estimation method we have compared here. First one is MLE. As we all know, MLE is the most effective estimation method in the literature. So here we will first find the log likelihood function, and we will find the partial derivative with respect to the estimator, which we have to find the MLE. So I have done similarly. So equation 7 will give the log likelihood function. Equation 8 will give the partial derivative with respect to eta, and equation 9 will give the partial derivative with respect to zeta. Equating this 8 and 9 to 0, we can find the MLE of the parameters. So here additionally, I have used bootstrapping to get the best result and highest density interval. So next method we have used here Bayesian estimation. Bayesian estimation, here we have two parameters, eta and zeta. Since eta is greater than 0, we have used gamma price, and modulus of zeta less than or equal to 1, we have used beta price, and it is we have reparameterized it to 2 zeta minus 1 for it to come into the interval minus 1 less than or equal to zeta less than 1. So here we uh, found the posterior distribution by multiplying the likelihood function into the prior distribution. So we have applied the no utrient sampler, that is NUTS, to approximate the posterior distribution, which help us to ensure the better convergence. So the third method is the machine learning technique, that is BNN. BNN is the combination of neural network and Bayesian estimation. So we have taken the same initial step as in the Bayesian estimation here, same priors, same posterior, everything is taken. And here what we have done is we have given this prior distribution as weight of the neural network. So it has increased the accuracy of the estimator. So here it is the result. So we have taken for four different sample sizes, and we have taken eta equal to 1.5, zeta equal to 0.5 as the true values. So from here we can understand that the estimated value using BNN is very close to the true value, and the lower HDI and upper HDI are intervals. So they are also very close to closed in BNN compared to the Bayesian estimation and MLE. So from the table, we can emphasize that the MLE method and Bayesian method face difficulties when the model is complex, and it will BNN give the accurate estimate as compared to the other two. So we have checked and compared the performance of the proposed distribution with the following distributions. First one is hyperbolic tangent inverse exponential distribution, co-stable distribution, Tessier distribution with the this following data. This data is taken from the state Minneapolis for the 30 consecutive days of precipitation rate. So this is, we have compared the data set, and we have analyzed this data set using these all four distributions. From the result, we can understand that this LL means log likelihood, AIC means Agaike information criteria, Bayesian information criteria, Hankin information criteria, KS means Kolmogorov-Smirnov value, p-value. So from here, the information criteria are very less in TTD. Information criteria means the amount of information losses when we are using some analysis. So here we can understand it is very low in TTD compared to the other two, and p-value is very high in TTD. So this is the violin plot of the data set. This is the TTT plot of the data set. This is the estimated PDF to the we have fitted to the histogram of the data set. These are the results. The violin plot showcases the spread of the density of the data set along with the median and quartiles across different values of the range. The TTT plot indicate characteristic of the hazard function of the given data. The curve is concave, indicating that hazard function is increasing. Table 2 shows that TTD gives the minimum value of discriminative measures compared to HT, i.e. cost W and Tessier distribution. The p-value of TTD is 0.8673 for given data set is also high compared to the others. So figure 5 shows the adaptability of the TTD to the histogram of the data set. So our conclusion is the TTD can be used to analyze data sets like environmental data set, and BNN can be used for better approximation to the actual values. It will give the actual values compared to the MLE and Bayesian estimations. We have derived the fundamentals of the proposed distribution compared to the HTIE, COSW, and TC distribution. TTD shows a better fit towards the precipitation data set. These are my reference I have used for this article. Thank you.
Thank you, Amrita. Here I have one question.
Yes, ma'am.
Can you give me the real life example of your this distribution that is called TG?
Of course, ma'am. I'm also included this analysis of the precipitation data set in this.
Environmental something is there, right?
What, ma'am? I can't hear that.
In your conclusion, you mentioned that this real life example is environmental sciences something.
Yes, yes.
So any what type of environmental values you
For
are saying that?
Yes, ma'am. If we have
Everything.
rainfall data or precipitation data, water availability, in this type of data, we can analyze using this
How?
distribution.
How?
How means we can, using the properties of the distribution, we can find the mean, variance, median, or something like that, the behavior, how it behave after some values. And if we plot the graph, we can understand how it goes, how the trend, all these kinds of things are analyzed using this distribution, ma'am.
Okay. One more question. That is, you used gamma prior, right?
Yes, ma'am.
Why you did not use the um, in uninformed priors?
Yes, ma'am. We can use some other distribution also. I used gamma prior because it is that parameter is greater than 0. We can use normal prior or uniform distribution, whatever it is we can use. But I think gamma prior gives the better result. That is why I used that.
Okay, so have you checked for other priors, or you are saying that it gives
No,
better
no, no.
in
I have,
gamma?
yes, ma'am. I have checked for uniform distribution, so it won't give that better result.
Okay, thank you.
Okay, thank you, ma'am.
Thank you, Miss Amrita.
Thank you, thank you.
Now I invite number 21, Miss Anjum Khatun.
Yes, ma'am. Hello. Hello. Am I audible, ma'am?
You are audible. Please share your screen.
Okay, okay.
You have just 10 minutes, so try to bind up between 10 minutes.
Okay, okay, ma'am. I skipped my introduction part. Ma'am, is this visible to you, ma'am?
No, no, no.
Oh, okay,
Yeah,
okay.
your screen is visible now. You can start.
Yes, ma'am. 1 second.
Please try to bind up as soon as possible.
Just a minute. Okay, ma'am. Myself, Anjum Khatun. I'm a PhD research scholar from Department of Statistics. Today, my research topic is mapping the expansion of IVF clinics in Bihar in the context of socio-demographic analysis under the supervision of Dr. Amit Kumar, Head Department of Statistics. So this section belongs to the abstract of my study. India have the IVF market has grown rapidly in the recent year with the over of the 1,500 clinic performing nearly the 250,000 cycles annually. Basically, my study aimed to fill that gap by analyzing the geographical spread, service availability, and the institutional characteristics of the IVF clinic across the Bihar state. It also examined various factors like that related to the infertility, or the we can say that the childless issues, infertility prevalence, economic condition, healthcare infrastructure, and the healthcare facilities also. So hopefully this research aims to inform the better access of affordability and equality in the IVF across in Bihar. So this is the background of the my study. So as we know that the all of us offspring, the procreation is a natural process, and every couple demanded it, but due to the recent year of the some lifestyle factor or many more reasons, this is the increasing issues of in today's life. So reproductive health issues addressing also in the sustainable development.
Hello, Anju.
Hello. Yes, ma'am.
Dear, come to your objective and results and conclusions.
Oh, okay, ma'am. Okay, ma'am. Ma'am, I skip background, literature review, all these sections. Okay. So this is the objective of my study. These are the objective of my study. Just wait, ma'am. So basically, these are the total. I have taken the 5 objectives, but primarily aim to analyze the growth of the distribution of IVF clinics in Bihar, and I also seek to understand the how factors like infertility rate, economic condition, and influence this expansion. Ultimately, the goal is to generate the insight that can support the more accessible reproductive across the state. So methodology. I have used the mixed method approach. This is the result section. So my first objective, I have tried to explain by this column chart growth of the IVF centers, and by this I have found Patna as a hub of the IVF center, host of the 60 to 95 IVF centers. Basically, the IVF centers in the urban cities more increasing infrastructure and accessibility, and the highest success rate, modern technology, and affordable pricing. But there are the some district in Bihar, predominantly rural district. Here I have mentioned Samastipur, Kishanganj, and many more districts are there. There is no IVF clinics are there, and if there is availability in the government hospital, maybe 1 or 2, less than 2. So these are the, and second is the result in the institutional profile in Bihar urban IVF. So I have taken the parameter as a ma'am, average IVF cycle per year, ownership of the clinics, private or the public, average cost per cycle that have taken the treatment in the IVF center, embryologist, and the counseling services. So I have categorized into the 3 category: urban center, semi-urban, and rural areas. So these results are I have found, and this is the analysis table. I have used the rank correlation and the chi-square test for this comparison, and I have found that the strong positive correlation of the IVF center with the most urbanized district in Bihar, and significant correlation association between the district classification and the IVF center. Basically, IVF center are where there is a urbanization, healthcare facilities. As a Patna, this is the as the earlier slide we have seen Patna as a hub, but beside the Patna, rest of the district are actually awareness is also lacking there. So IVF treatments so far. Cost and affordability analysis. So cost factor as also described into the 3-part: urban, semi-urban, and the rural. So in urban, if we take the IVF treatment, 85 to 1,60,000 per cycle, and the if we go to the semi, 75 to 120 lakhs, and the 60,000 to 1 lakh in the rural areas. Basically, there is a many more lacking point. Some clinics are provide the loan providers or the AMI options, home IVF. So many more factors are there. Socioeconomic infertility data correlation. So socioeconomic factor basically associating with this treatment. If there is a in the rural area, as we know that Bihar is the third most populous state in the India. So there is the basically the emphasis of the rural and the urban population. So socio-economic factor basically in the treatment have taken by the patient. Sorry. Yeah. Sorry. So I am go to the conclusion. In 2025, IVF centers in Bihar are heavily concentrated in Patna due to its urbanization and strong infrastructure, while semi-urban areas are the limited growth and district private ownership dominating, making the treatment unaffordable for the many reasons. To ensure the equitable, accessible, Bihar needs the public investments, subsidize incentive, insurance, and the better regulation. Expansion of IVF services fairly is to keep the improving reproductive health across the state. And these are the recommendations are there, and these are references that I have used. Thank you for the attention.
Hello.
Hello, yes, ma'am.
Anju, have
Hello. Can you
Hello,
hear
yes,
me?
ma'am. Hi, yes, ma'am.
Hello.
Hello, yes, ma'am. I can hear you.
Yes. And so, which type of data you used for this study?
Ma'am, both are type of data. Some I have taken from the hospital, just like there is a AIMS Patna and PMCH, and some are the ma'am website, our clinic website are also available there. So just like the Birla IVF Nova, तो और अब हमारे पास दूसरे भी कुछ है मैम, ART एंड सेरोगेसी पोर्टल्स आर देयर, कुछ गवर्नमेंट, कुछ मतलब बोथ आर मैम, प्राइमरी एंड सेकेंडरी, और कुछ वेबसाइट के डेटा, तीनों को मैम मैंने मिक्स करके तो किया है.
It was one thing that's how you
Yes.
choose this topic. What
Actually,
you have.
ma'am. Hello.
Yes, yes. Hello.
Hello. Hello. Yes, ma'am. Please, can you repeat, ma'am?
What is the history to choose this topic?
Okay, ma'am. This is the history behind this choose. I have, ma'am, there are two reasons. Firstly, ma'am, in my family, the genetic issue are there. So बहुत सारे ऐसे हैं मैम, cousins हैं जिनके ये मैम ये प्रॉब्लम है, इनफर्टिलिटी वाली प्रॉब्लम है. और सेकेंड ये जो प्रॉब्लम है मैम, ये IVF वाली, कि जैसे आज अभी के टाइम में क्या हो रहा है कि हम लोग किसी भी स्ट्रीट से क्रॉस कर रहे हैं, कहीं भी जा रहे हैं, तो एक जगह एडवर्टीजमेंट हर जगह हम लोग इन चीजों की देख रहे हैं कि IVF जो है वो इस तरीके से है, ये है, EMI ऑप्शंस है, बहुत सारे हैं. तो एक एडवर्टीजमेंट को देख के भी मेरे अंदर आई, और प्लस ये फैमिली वाला तो जरा थोड़ा इशू था, और तो यही सोच के मैंने ये चॉइस किया.
hello.
हेलो मैम, एक्चुअली हेलो.
Thank you, Anjum. Now I call number 22, Anusha. Miss Anusha.
Hello.
Okay, ma'am. Thank you. There is some technical issues also.
Hello.
Miss
Hello.
Anusha.
Yeah. Can I start?
Yeah, you are audible. Please share your screen. Miss Anusha.
If I'm sharing.
Am I audible?
Hello.
Am I audible to you?
Yeah, I can hear you. Is my
Your
screen
voice is,
visible?
hello.
Hello.
Your voice is so soft. Please.
Hello.
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 Yeah, you are audible now.
Is my screen visible to you?
Yeah, your screen is visible. You can start now. But remember that you just have 10 minutes. So please try to bind up between 10 minutes.
Okay, fine. Greetings, everyone. I'm Anusha Ilisaji, currently doing Masters in Statistics and Data Analytics from Lovely Professor University, Punjab. The title of my paper is Predicting the Future of Sustainable Finance, a Statistical and Machine Learning Analysis of ESG-driven investment portfolios. Moving to the first slide, motivation or background. Globally, environmental, social, and governance or ESG assets have surpassed 30 trillion US dollars, which accounts for nearly one third of all global investments. This highlights the increasing importance of sustainable finance, which aims to balance financial returns with sustainability outcomes. However, there are two central debates in the literature. First, do ESG portfolios really outperform traditional portfolios in terms of returns and resilience? Second, among the three pillars, environmental, social, and governance, which one matters the most for driving performance? Most existing studies focus only on descriptive reporting of ESG without providing predictive uncertainty aware models. Our study addresses this gap by using statistical and machine learning techniques to predict ESG driven portfolio performance. Moving to the next slide, research objectives. Our study was designed around five core objectives. First, to examine whether ESG portfolios perform better than traditional portfolios. Second, to measure the relative contribution of the three ESG pillars. Third, to apply both statistical models such as linear, ridge, and Bayesian regression, and machine learning models such as XGBoost and random forest. Fourth, to provide uncertainty-aware forecast by employing Bayesian regression, and finally to link these results to the United Nations Sustainable Development Goals, particularly SDG 8 on economic growth, SDG 12 on responsible consumption, and SDG 13 on climate action. Moving to the next slide, literature review. The literature on ESG performance shows mixed evidence. Some studies find that ESG portfolios match or even outperform traditional ones, while others show that results depend on region, time horizon, and methodology. Since 2020, many researchers have started using machine learning methods like random forest, XGBoost, and deep learning, which often outperform traditional econometric models by capturing nonlinear relationships. A consistent finding is that ESG funds tends to show greater resilience during crises such as the COVID-19 downturn. Among the three pillars, the environmental dimension is repeatedly shown to be the most influential. However, very few studies integrate Bayesian methods to generate probabilistic forecasts, leaving a clear research gap that our study addresses. Moving to the next slide, data and sources. Our study uses data from S&P 500 firms. We collected firm-level ESG scores across all three pillars, environmental, social, and governance, along with the total ESG score. We also obtained daily stock prices, which we resampled into monthly frequency to calculate returns. We then merged these into a panel dataset combining ESG scores with monthly returns. Moving to the next slide, methodology. Our methodology had five major steps. First, we constructed a benchmark portfolio representing the average market return. Second, we defined an outperformance indicator equal to 1 if a firm's return was above the benchmark and 0 otherwise. Third, we sorted firms into ESG quintiles from Q1 with the lowest ESG score to Q5 with the highest. Fourth, we applied a mix of regression models, linear, ridge, XGBoost, and Bayesian, and classification models, logistic regression, and random forest. Finally, we evaluated the models using metrics such as R squared and MSE for regressions and accuracy, precision, and recall for classifications. Moving to the next slide, visualization approach. We used three main forms of visualization. First, cumulative return plots to compare performance of ESG quintile portfolios. Second, random forest feature importance charts which rank the relative influence of environmental, social, governance, and total ESG scores. And third, tables of model performance metrics to assess accuracy and fit. Moving to the next slide, key results regression. Let us look at the regression models. Our linear regression showed an R-square value of 1.0, a perfect fit. In finance, such perfection is nearly impossible, so this result must be interpreted cautiously. It occurs here because we use aggregated quintile portfolios where returns are highly structured and easier to explain. ridge regression with an R-square value of approximately 0.21 and Bayesian ridge with an R-square value approximately 0.15 gave more realistic fits since they penalize overfitting and incorporate uncertainty. Exhibits also fit extremely well with an R-square approximately 0.99, showing its strength in capturing non-linear ESG effects. While the Bayesian model explained less variance, its purpose was different. It provided uncertainty-aware forecasts, generally probability distributions, rather than single-point estimates. So the results show that ESG scores can explain cumulative portfolio returns very well in linear and ensemble frameworks, but the Bayesian approach contributes by adding credibility through uncertainty quantification. Moving to the next slide, key results classification. Next, we evaluated whether ESG scores could predict if an individual stock would beat the benchmark return in a given month. The logistic regression model achieved an accuracy of around 51.8%, while the random forest classifier performed slightly better with 53% accuracy. These results are only slightly above random guessing, which means ESG scores are not strong short-term stock pickers. However, random forest consistently outperformed logistic regression across precision, recall, and F1 score, suggesting that ESG does contain some predictive signal when interactions are modeled. Moving to the next slide, portfolio performance. When we compare portfolio level results, the findings are very clear. Portfolios with higher ESG quintiles, especially Q3 to Q5, consistently outperform those with lower ESG scores. The top quintile portfolio Q5 achieved more than 25% cumulative growth over the sample period. Moreover, during times of market downturns, higher ESG portfolios displayed greater resilience, acting as a form of downside hedge. This finding supports earlier regulatory and academic reports that ESG portfolios tend to be more stable in turbulent times. Moving to the next slide, random forest feature importance. The random forest feature importance analysis ranked the predictive power of different ESG dimensions. The environmental pillar came out as the strongest predictor with an importance score of 0.32. Next was the total ESG score with a 0.28, followed by governance and social, both with the scores of 0.20. This confirms that environmental performance, for example, carbon exposure, climate regulation compliance, and resource efficiency is the most material factor for long-term portfolio success. Moving to the next slide, discussion. From these findings, three key insights emerge. First, the environmental pillar is consistently the strongest driver of financial performance. This aligns with the growing global recognition of climate risk in capital markets. Second, while ESG scores do contain predictive information, they are more effective at portfolio level forecasting than at predicting individual stock outperformance. Third, combining machine learning with the Bayesian methods provides depth. Machine learning models capture complex non-linear patterns with high accuracy, while Bayesian methods incorporate uncertainty and make the forecast more trustworthy. Coming to the conclusion, our study provides strong evidence that ESG portfolios, especially those with high ESG scores, deliver higher long-term returns and greater resilience than lower scoring portfolios. We also confirm that the environmental pillar plays the most crucial role in driving performance. Finally, the methodological contribution of the study is clear. By combining statistical, machine learning, and Bayesian methods, we demonstrate both the predictive power of ESG and the importance of acknowledging uncertainty. These results support the UN Sustainable Development Goals, SDG 8 on economic growth, SDG 12 on responsible consumption, and SDG 13 on climate action. Talking about the future work, several directions are possible. We can incorporate firm-level disclosures such as carbon intensity, supply chain transparency, and broad diversity to improve granularity. We also propose using advanced deep learning architectures like LSTMs and transformers to model temporal dynamics. Further, extending the study across emerging markets will enhance generalizability. We also plan to integrate alternative data such as satellite imagery, text mining, and sentiment analysis. Finally, scenario-based simulations, for example, under a carbon tax, could provide valuable insights for both investors and policymakers. Moving to the next slide, the implications of our research are significant. For corporations, ESG integration strengthens long-term competitiveness and builds investor trust. For policymakers, our results stress the importance of standardized sustainability disclosures and accountability frameworks. And for investors, ESG integration is not only an ethical strategy, but also a financially viable one, especially at the portfolio level. Taken together, our findings show that ESG-driven investing can simultaneously deliver profitability and sustainability. To summarize, our objectives were to evaluate ESG versus traditional portfolios, test the statistical and machine learning models, assess pillar-level contributions, and link results to the SDGs. We achieved these objectives. ESG portfolios, especially in the top
So
quintile,
time is
outperformed.
over there. Hello.
Yes, sir, I'm concluding. Just two more points.
Just conclude it first.
Yes, sir. Linear and XGBoost regression models fit extremely well, while Bayesian added uncertainty our forecast. Random forest showed the environmental pillar dominates predictive power. Classification results confirmed ESG is better suited for long-term portfolio resilience than for short-term stock picking. Thus, the future of sustainable finance lies in integrating machine learning, Bayesian statistics, and robust ESG data to guide ethical and profitable investments. That's it. Thank you for paying attention.
I have just one question, Tanisha.
So,
How we can connect environment as a strong predictor in your thinking?
so 1 second, sir.
Am I audible?
Oh,
Hello?
hello.
Yes. Am I audible to you?
Yes, sir.
Okay. How we can connect environment as a strong predictor?
Uh, you are asking about environment?
As a strong predictor. You have used this term in your paper.
Hello. Am I audible, sir?
Yes, you are audible.
Okay. Sir, in this project, I have used random forest analysis, showed that the environmental pillar was the strongest predictor of portfolio performance, even more than social and governance. This makes intuitive
Okay.
sense when we connect it to the real economy. Environmental risks
Okay.
like carbon emission, climate regulation, resource efficiency, and pollution penalties have direct financial impacts on firms. For example, companies with high carbon footprints may face higher costs due to carbon taxes or stricter regulations, while firms investing in renewable energy and sustainability often gain competitive advantages and investor trust. So, the dominance of the environmental pillar in our study is not just a statistical outcome, it reflects the fact that climate related risks and opportunities translate directly into financial performance. I hope I was able to answer the question, sir.
Sure. Sure. Thank you.
Thank you, sir.
Thank you, Ms. Anusha. Now I invited number 23, Mr. Shivam Dixit. Shivam Dixit.
Yes, ma'am.
Mr. Shivam Dixit.
Yes, ma'am.
Yeah, you are audible now. So
Yes,
please share your screen. Remember that you have just 10 minutes. So please try to bind up between 10 minutes.
Ma'am, so हो रही है टेबल?
Yeah. Your screen is visible now. Please try bind up as soon as possible because
Yes, ma'am.
we
Yes,
have a
ma'am.
lot of.
Myself, Shivam Dikshit. This is College Statistics, Department of Amity School of Applied Sciences, Amity University, Rajasthan. My guide is Dr. Jagdish Prasad sir, Head Department of Statistics. My topic is maternal anemia as a critical determination determination of low birth weight, a state level analysis of nutritional and education risk factors in India using NFSS 5 data. Introduction: low birth weight remains a major public health challenge in India. Despite economics, progress, and expensive healthcare intervention, the prevalence of low birth weight in India remains high, with recent estimates remaining between 16.4% and 18.4%. 18% as per the large Nessa sample survey, NFSS 4 and NFSS 5. Low birth weight is strongly associated with the poor childhood development and higher neonatal and infant mortality and a higher risk of adult chronic disease. The rationale is Maternal anemia is a significant risk factor for low birth weight, which is a strong indicator of poor maternal and newborn health. The study aimed to quantify this relationship using the most recent National Family Health Survey NFS5 data for India. Low birth weight has long-term consequences on the infant health and development, making effort to reduce is crucial for improving overall public health. India's diverse state experience varies levels of anemia and low birth weight. Analyzing state level data allow for identification of specific regional challenges and tailoring intervention. By using NFS's data set, the study provide evidence-based insight to improve policy of programming decision for regions specific multidisciplinary strategy to prevent and treat anemia and low birth weight. My goal, the pinpoint critical mental health and socioeconomic factors that significantly influence low birth weight prevalence, thereby providing evidence for the target policy intervention. Aim of the study aimed to examine the prevalence and clustering of key maternal indicators such as nutrition measured by the low BMI less than 18.5, adolescent child wearing, anemia prevalence among pregnant women, cover of full antenatal care ANC, and female educational attainment more than 10 years of schooling. By assessing these variables at the state and union tertiary levels, the researchers seek to identify the extent of variability and the interrelationship among these determinants. Objective of the study, the analysis region variation in maternal health indicators BMI, anemia, teenage childbearing, maternal care ANC, and female education. Using secondary data from the National Family Health Survey NFS5, were analyzed using descriptive statistics to identify key predictor of low birth weight prevalence through correlation analysis and multi-logistic regression. Methodology. Study design is secondary data-based descriptive statistics. The units of study population, the units of analysis where the India has eighth union tertiary and 28 states and 707 districts between 2019 and 2021. Maternal indicators analyzed using including the prevalence of undernutrition measure as proportion of females with BMI less than 18.5, teenage childbearing rates, birth among women is 15 to 19 years, female of anemia in pregnant women, full ANC coverage, and female educational attention percent of women who has complete at least 10 years of education. Data sources, the data sources come from 15 rounds of National Family Health Survey NFS 5 under the direction of Ministry of Health and Family Welfare of the Government of India. The study was organized by the International Institute of Population IIPS located in Mumbai. Statistical analysis data from National Family Health Survey were analyzed using descriptive statistics to assess region variation in mental health indicators, BMI, anemia, teenage childbearing, antenatal care, and female education. Correlation analysis and logistic regression modeling to identify key predictor of lower. Table 1 shows the significant variation in the maternal health and educational indicators linked to low birth weight risk across India state level. On average, 13.2% of women have a BMI below 18.5, indicating undernutrition, with some states like Bihar experience rates highs as 25.6%. Early childbearing affect 6.8% of women aged 15 to 19 years, with the certain states like Tripura reported rates as high as 21.9%, which increase low birth weight risk. Anemia prevalence is notably high, averaging 52.8%, underscoring its role as the critical mental health challenging. And Tripura reported high prevalence rate of 71.4%. Full antenatal care coverage averages 41.2%, but many states like Nagaland and Bihar lack significant highlighted gaps in maternal health care access. Women educational attention shows moderate level with 58.5% having at least 10 years of schooling. High education state like Kerala, 80.2%, many years of schooling, more than 10 years, correlated with the better maternal and newborn outcomes. Overall, these indicator reveals district states level that influence low birth weight prevalence, the needs of the target nutritional, education, and health intervention of mitigate low birth weight risk and the improve maternal health, child health outcome. Table 2 shows the correlation analysis reveals significant relationship among maternal health and education indicator across India state. The higher rates of undernutrition, BMI less than 18.5 are positively associated with the increase in childbearing and anemia prevalence, while negatively correlated with the full antenatal care coverage and maternal education levels. Specifically, state with the higher undernutrition tends to have higher teenage pregnancy rate R is equal to 0.37 and anemia prevalence is 0.45 R is equal to, and positively correlated, and were characterized by the lower coverage of comprehensive antenatal care R is equal to minus 0.65 negative correlation, and fewer women attending at least 10 years of schooling R is equal to minus 0.65. Similarly, higher maternal education level are strongly associated with the increased antenatal care coverage R is equal to 0.66, and reduce undernutrition and anemia. The positively correlated between the teenage childbearing and anemia R is equal to 0.448 underscore the clustering of reproductive health risk, whereas the near zero correlation between the anemia and antenatal care coverage R is equal to minus 0.05 suggests that anemia prevalence might be influenced by the factor beyond just ANC. These findings highlight the interconnected nature of maternal health, nutritional, and educational, and suggest that strategies aim to improve maternal education and health care assist could effective address multiple occurring risk factors associated with the low birth weight across India. Table 3, the logistic regression analysis identify maternal factors influence high low birth weight prevalence across India state. The maternal anemia was the only predictor which was statistically significant, or ratio is 1.50, which indicates that each 1% increase in the anemia prevalence increase the odds of states having a high low birth weight burden by the 50%. Other variables such as the proportion of women with low birth BMI less than 80.5%, teenage childbearing, and full antenatal care should positively or negatively associated with the high low birth weight prevalence. However, these do not reach statistical significance. For instance, hello,
Hello, Shivan.
जी मैम.
Please try to bind up because you just have 2 minutes left.
Okay, ma'am. Okay, ma'am. For instance, higher undernutrition was associated with the increased odd ratio 1.47, but this was not statistical significant. Similarly, teenage childbearing and antenatal care coverage demonstrate positively and negatively associated with the respectively, but without significant conclusion. The analysis of maternal health and education indicator across India state clearly reveals the complex interplay of the variable effect low birth weight, reveal education, healthcare, reproductive, and nutrition. Among these, maternal anemia states out of the most critical and statistical significance. This factor is strongly associated with the low birth weight prevalence, which under nutrition, adolescent childbearing, full antenatal care, and women education, but so improvement relationship with the low birth weight risk. Their effect was not statistically significant in the state aggregate data, possibly due to the data set limitation. At the same time, the positive correlation between the educational and antenatal care and their negative associated with the undernutrition, teenage pregnancy, and anemia implement integrated. Multi-facts program runs maternal nutrition, reproductive health, education, and healthcare assist will be essential for the sustained improvement. This is reference. Thank you. Hello.
Am I audible?
हाँ, yes.
Am I audible, Shivam?
हाँ जी सर.
Future scope of your research?
Hello.
Are you able to?
हाँ सर, हाँ जी बताइए सर.
What is the future scope? What is the future scope of your research? Can you explain?
सर, लो बर्थ वेट को कैसे कम कर सकते हैं? बेसिकली इंडिकेटर्स, मतलब कैसे इंडिकेटर्स जो हैं, जो मतलब अगर फाइंड कर लें जिससे लो बर्थ वेट कम हो सके सर इंडिया का, बेसिकली.
Okay.
ChatGPT.
तो बहुत सारे फैक्टर्स हैं सर
Okay.
जो अफेक्ट करते हैं वुमेन्स को, जिसके कारण है ना सर, जो लो बर्थ वेट को इंक्रीज करते हैं सर।
As example,
माई माई एम तो
what are the
एक मॉडल को डेवलप
factors?
एक मॉडल को डेवलप करना सर लास्ट में, माई पीएचडी, क्योंकि माई टॉपिक इज सर स्टैटिस्टिकल मॉडल को बनाना सर, बाद में लास्ट में पीएचडी।
Yes, sir. Yes, sir. Yes, sir. Thank you.
थैंक यू
Thank you,
मैम,
sir.
थैंक यू मैम। ठीक।
Now I invite to Vishal Kumar. Vishal Kumar,
Okay, ma'am.
please share your screen and remember that you just have 10 minutes. Please try to find a participant. Please share your screen. Vishal, please share your screen.
Yes, ma'am. I'm sharing my screen.
हाँ, तो दिख रही है screen?
Ma'am, there is a problem. मैकबुक में ये शेयर नहीं हो रहा, मे बी मैं फोन से ज्वाइन करता हूँ।
Do it one more time.
Miss Ishita. Miss Ishita, 25. Number 25. Miss Ishita.
Ishita, are you there?
Vishal, are you able to share your screen? Mr. Vishal. Mr. Vishal, are you able to share your screen?
Guys, you please open your cam. So we are able to click our pic.
नहीं ये मैं से क्या करूँ इसी पे लो ना इस पे लो ना स्क्रीनशॉट मेरे मुझे अच्छा मेरी किसी को माइक आपके भी
Everyone, please open your cam.
All the participants are requested to open their cameras. Hello, am I audible?
All the participants are requested, please put on your camera. We are going to take up a short
Please, all the participants are requested to open their camera.
Hello Anusha, how are you?
Hi, ma'am. I'm good. How are you?
Fine, fine. Hello Vishal. Hello Vishal. Am I audible?
Hi, is somebody speaking? Because I'm not able to hear anything. Hello, ma'am.
Hello Vishal.
जी मैम, आवाज आ रही है मेरी?
Yes, yes, yes. Vishal, you
स्क्रीन
have just
शेयर
10
हो रही है?
minutes. Okay. Hello.
सॉरी मैम.
Yes, you have 35 slides.
Oh, I'm starting. Greeting to all. Myself Vishal.
Vishal, you have 10 minutes. Okay, just jump on your objective and results and conclusions. Okay.
Okay, ma'am. Okay. So myself, Vishal Kumar. I am research scholar of Central University of Haryana. Currently, I am pursuing PhD from Central University Haryana under the supervision of Dr. Anup Kumar. Today, I am presenting my research work on the topic of improved neutroscopic imputation techniques for the population mean in presence of uncertainty. So now these are the introduction slides, and these are the literature review. And now we have notations which are used in following neutroscopic imputation framework. Further, uh, further we have the adapted neutroscopic imputation method and the neutroscopic ratio imputation method and the neutroscopic regression method and the neutroscopic power ratio imputation method, neutroscopic logarithmic imputation method. So these are my proposed work on the neutroscopic imputation method. So the proposed enhanced neutroscopic imputation method for estimating population mean under simple random sampling are provided in method first, second, and third, and corresponding resultant estimator given in equation 14, 15, and 16, where alpha and phi j are optimizing scalar and g or gn and theta are constant. These are the minimum MSC for the proposed estimator given in equation 17. These are the constant. These are the value of A1, B1, C1, D1, E1, and these are the simulation studies. Simulation study is important for verifying the theoretical results for the following seen and on 1998. The following models are used to generate the neutroscopic data. These are the model given in equation 18 for the simulation study. So generate a symmetric population for the neutroscopic normal distribution of n is equals to 1000 with these values using for the simulation, and select a sample nn 300 to 300 from the neutroscopic normal population generated in above step, and compute the MSC and PRE of the neutroscopic estimator for the sample and corresponding units selected in previous step. Now we interpret the simulation findings from the table 1. From table from table 1, we have seen that the proposed estimator have minimum MSC, minimum mean square error, compared as the neutroscopic mean per unit, ratio estimator, and power ratio estimator, and logarithmic estimator. Similarly, we can see that the dominance of the proposed estimator in method second and third. Similarly, we can see in table 2 the dominance of proposed estimator in first method and second and third. These are the real data study. So in this data, neutroscopic variable yn is varying pricing the stock on each day from the 19 May to 2023. So while the neutroscopic auxiliary variable xn is the varying price of the stock on each day from the 19 May to 2022. So these are the real data descriptives. So the findings of real data are displayed in table 4. Table 4, the MSC of the proposed estimator is the smallest compared to the MSC of the neutroscopic sample mean, neutroscopic ratio estimator, and neutroscopic regression estimator, and neutroscopic power ratio estimator. And also the PRE of the proposed estimator, TP, is the largest compared to the PRE of the adaptive neutroscopic estimator. So moreover, the performance of the proposed and adapted nucleoscopic imputation method is superior under method second among the three considered methods. This is the table 4. And now we are conclude that in this article, we introduce nucleoscopic imputation method and corresponding resultant nucleoscopic estimator of the population mean with their properties under simple random sampling and the characteristics like Wise and MSE of the proposed estimator, proposed resulting estimator are obtained to the first order approximation, and the proposed efficient nucleoscopic imputation method consistently provide more accurate and reliable estimates over the adapted nucleoscopic imputation methods under the condition established in the analytical study. So the simulation findings exhibits the superiority of the proposed nucleoscopic imputation over the adapted ones. So the usefulness and practical relevance of these methods are further supported by examples from the nucleoscopic real data, highlighting their importance in improving the accuracy and reliability of the statistical conclusion. Thus, the proposed efficient nucleoscopic imputation method can be used for the estimation of population mean in the presence of missing data, provided data are the nucleoscopic. These are the references, and thank you.
Thank you. Now I invite Isita. Isita, are you there? Isita Singh. Isita, are you there?
Hello, Ishita.
I think Isita is not here. So end of the session.
Thank you to all the presenters for their excellent contributions and to our audience for their active participations. A special thank to our session chairpersons, Dr. Ambrish sir and Dr. Sampriya ma'am. Dr. Prem Pratap ma'am, sorry ma'am. This concludes our sessions. We wish you all a wonderful rest of your day and look forward to seeing you at future academic events. Thank you and goodbye. Thank you for all the participants.